I hope. Cool. Leave this one.
Я попрошу, я спробую.
Cool.
Жаль, я не знаю, як прочитати режим доповідача. Я піду вашим методом. Прошу, затримку. Да, я прошу. Ну, тепер буде знати. My master project dedicated to customer lifetime value for retail based on transactional and loyalty card data. To start with, I would like to provide you the introduction to domain area. So we will see the definition, importance, challenges, and set up the goals of this project. Then we will come to CLV modeling approaches overview. Then we will consider proposed model, probabilistic and econometric approaches. Then we will come to data. We will check the pipeline and how I prepare the data sets used in the research. Then we will be back to probabilistic approach and, oh, sorry, I missed a step. So we will consider also clusterization technique, and we will decide which one is better for our particular case. We will choose between Kamins, Gaussian mixture model, and DB-scan. Then we will be back to probabilistic approach, and we'll consider consider Markov Chain and derive CLV values from there, and we will also check the business values. Then we will go back to econometric approach and explore time series alongside with survival analytics and derive CLV values from there. Then we come to conclusions, check the limitation of my approaches. I come to acknowledgements and answer to the question of review. If we will have enough time, we can discuss the future work of this project. Okay. So in 1974, Kotler defined customer lifetime value as the present value of future profit stream expected given a time horizon of transacting with the customer. So different researchers define customer lifetime value differently. However, the general idea is that this metric indicates the total revenue a company can expect from the relationship with a particular customer. And when we are talking about customer lifetime value calculations, we mean two parts. So the present part, which can be derived from the historical data, and the future part, future value, which we model, estimate with our modeling. Of course, CLV metric is very important, and according to PwC and McKinsey, this company uses the analysis of CLV, and they state that this provides a 360-degree view of the client situation, and this measurement can be used for value maximization on customer level, and as a result, the increase of revenue of a company. So with this metric, we can make the data-driven decision towards resource allocation, marketing strategies formulation, building a long-term relationship with the customers. We can use it for effective management of marketing investments, retaining and acquiring customers. We can use it for estimation of company value and evaluation of marketing channels and campaigns. In retail, CLV have two challenges. The first one is customer identification. We have to build a historical reference with a particular customer. And the second one is a lack of publicly available transactional data sets to validate theoretical aspects. The matter is that there are a bunch of articles which represent the theory of CLV modeling. However, only a few of them dedicated to empirical studies, and only a few use transactional data in their research. So the reason is that the companies who did research in retail, they all these results have proprietary nature, and the companies rarely reveal the results to society to stay competitive on the global market. So the practical goal of the project is to create an applicable analytical framework for offline and semi-offline businesses to run CLV forecast for channels and campaign evaluation. And to reach this goal, we have to solve three tasks. First, investigate existing approaches to CLV modeling suitable for offline retail businesses. Then develop two-component CLV model, cluster customers, and predict revenue relevant to the cluster of interest based on available transactional and loyalty card data. And after that, we compile models based on the assumption limitations and advantages for offline store environment. In 2006, Sanil Gupta from Harvard Business School classified all the approaches towards CLV modeling, and he split them into deterministic and stochastic, and these two approaches combined together recency frequency monetary value approach, growth and diffusion, probability, econometric, persistence, computer science. Here is the problem that different researchers who created this model decades ago, they had different contexts for different businesses, and they also use different data sources in their research. So it could be survey, some reported data, or customer databases. In a year ago, Pavel Jacek from Prague University, he published a work, and he said that if you are dealing with transactional data, so only two variant you can choose, the probability and econometric approach. Okay, so the first approach I used in my work, it's probabilistic. It has Markov Chain in its heart. And for this approach, we first should cluster customers, then use this clustering result to build a transaction matrix, simultaneously calculate average revenue and average retention score per cluster. As a result, we will obtain the estimation of CLV for the period of interest. And the second approach is econometric, which have two branches. The first one is time series prediction of revenue, and the second one is revival analytics. And with this approach, we will predict the lifetime duration of customer. And with a given period of interest, we estimate the customer lifetime value. And then at the end, we will try to compare both approaches. All right, so what kind of data we used in the research? The data was provided by industrial partner, and since we signed the NDA, me and my supervisor with this company, we cannot disclose any personal information. However, this is a gross retail chain in the United States, and the data we obtain, it contained transactions and loyalty card data from 12 grocery stores, having 500,000 unique customers and 2 years of transaction. Among other entities, this data contained transactional IDs, data of purchase, UPC, something like barcode, quantity, regular price, discounted price, and loyalty card number. Actually, a loyalty card number we will use to identify the customer. But it was raw data, and for research, there are different models, so we have to prepare the data set for modeling, and the data first should pass through the data preparation pipeline. So the data was cleaned, we generate the features, and then we will apply dimensionality reduction and data preprocessing where it was needed. And as a result, we obtained 3 different data sets. First one used for clustering and Markov Chain, second one for time series forecasting, and the third one for lifetime estimates. At this stage, we have data, we need to cluster customers. So my assumption is that I don't have any business requirement, and I don't have any prerequisites how many clusters I would like to find in my research. And also, I know that there are 4 different clusterization, for different type of clusterization, which can be used. It's centroid distribution density and connectivity models, and I decided to choose the one representative from each of the approach except the last one. So I choose Kamin's Gaussian mixture model and DBScan. The features which I use to build the data set, it was recency frequency monetary value, churn binary value, kind of discounts, how many they were applied, and what was the amount of money saved for a particular customer, the proportion of money spent on the main 15 categories of products, and some loyalty program features, something like how many cards the customer have, and how many days passed since the card was issued. So the aggregation were based on 4 big months, and for Kamin's and Gaussian mixture, I run. I have to decide how many clusters I need to choose, and I run the test for homogeneity using within cluster sum of square and silhouette score. I run the clusterization technique from 2 to 50 clusters. And then also I build a distribution of customers within these clusters. And there were no unique solutions, so I decided from these 2 clusterization technique, Kamins and GMM, I decided to pick up 3 top with the best balanced distribution of customers within the cluster. It was, the number of clusters were selected 17, 20, and 21. Also, I was trying to work with DBScan as it's considered as promising clusterization technique. However, I didn't reach the goal. I tried parameter tuning, but seems like the clustering are really sparse, and DBScan just merging together. So the result of DBScan was omitted from my further research. All right, so now we come to Markov Chain, and Markov Chain is a probabilistic model that describes a sequence of possible events, where the probability of transition from one state to another depends only on the state of previous event. So these states can be described by a transition matrix, which represents the percentage of customers who moved from one segment to another. During some period, and in our case, it's 1 month. The data set which was used for Markov Chain is the same as we used for clusterization. We used 20 months for modeling and 8 months for test. So right now we have 6 different labels set obtained from clusterization technique, and we repeated the data manipulation for each of these label sets. We obtain the transition matrix, which rows value represent the current ones, and columns represent the next months. And it's the deeper color is the higher probability that customers would change one cluster to another one. All right, so we obtained transition matrix, we calculated average revenue per cluster, and we calculated average retention rate per cluster. And we estimate the CLV for the next 8 months. Now we compare it with actual data and see that the best result was obtained for communes with a number of clusters of 21. And later we will use it in our further research. Here I would like to mention that despite the fact that this method, Markov Chain, is really rough, it still shows a very good tendency of the revenue of each cluster. So with this slide, I would like to show that knowing CLV is very important. This value is very important. However, we still need to pay attention for the visualization we could use. For instance, this transition matrix could be represented as a Sankey diagram. And this kind of representation help us to understand how the cluster was formed and what is the proportion of customers in each cluster is. So another thing is that if we check predicted average CLV versus current revenue and we plot it alongside months axis, so this ratio, and if this ratio would go up and to some maximum point, and we could estimate that it's a positive trend, this cluster will have a positive trend, and for these guys we could offer some promotions. And if this trend shows decline, it means that some recommendation toward retention should be advised. Should be applied. Now we come to econometric approach, and first we consider survival analytics part of this. I use Cox proportional hazard model. It's a regression model used for investigating the effect of several variables at the time when the specified event is going to happen. And to run this regression, I prepared a data set based on the following features: churn, duration, frequency and monetary value, mean check, standard deviation of check, days since the card was issued. So the data set for modeling was based on the first 20 months, and it was split for train and test with a proportion 80 to 20. Okay, so later I used this model to predict the lifespan of the customers who stay with the company for the last months of the observation, and we can see on this figure that there are those who are going to churn with a high probability within a few days, and there are those who are going to stay with our stores forever, right? And so we modeled already. We estimated already the lifespan. Now we time to talk about time series and predict the revenue. So the data set included was built on weekly aggregations. Okay, sorry, yeah. I should go step by step. So that was the assumptions. What kind of data aggregation should I use? I can use daily, weekly, or monthly basis on a cluster or customer level. Monthly based aggregations was rejected from the very beginning because we don't have enough data. We have just 20 points, and we at least need to have 30 to our model perform well. So it could be weekly or daily. And then the question is, if I plot, well, I decided to plot the time series for individual customers, and we see for daily and weekly aggregation. And we see that this is, it's not actually time series. It's this intermittent data, and it should be forecast with other techniques. So I stayed with weekly based aggregation and pick up the promising cluster from Markov Chain model in its cluster number 9, and I run different. Augmented Dicker filler test showed that the first difference is not to obtain the stationary data. The evidence of seasonality was not caught by autocorrelation function and partial autocorrelation function. And the different ARIMA models were compared by Econometric, and the best one was ARIMA 011. And I see it predicted almost, well, it's slight decrease for $20, but for next 8 months, and it's same as, it's less than 1%, and it could be compared to just the average number of revenue as we used in Markov Chain. Then if we represent the revenue as average per cluster, and it's forecast to plot and plot the survival curves for each customer, which forms the cluster, we can check the average expected revenue from a single household and its stability over time in terms of lifespan. So for this particular cluster, the 9 cluster from Markov Chain, we see that the average CLV is about $30, and all the guys who stays in this cluster is going to be with us for the next half a year. And if you will be back to our Markov Chain approach and check this cluster stability, we obtain the same result. And it's a cool thing in this research that we can combine 2 approaches together and use it simultaneously. So now we come to conclusions. An analytical framework for planning semi-planned businesses was prototyped to estimate CLV based on transactional loyalty card data. This framework transfers the data obtained from the grocery store operational databases to business insight based on CLV estimations and AI visualization. It can be used for channels and comparing evaluation. The limitation are the following: that the framework was developed only on 1.5 year data and tested only on half-year data, and it can be significantly improved using a data set with broader data range, at least to make the monthly based aggregation for time series prediction. And the aim of the research and the framework development had a more conceptual character rather than accuracy oriented. Thus, there is a variety of methods which can be explored for more efficient revenue and true prediction in the future. And I would like to acknowledge, to express my gratitude to these people, my supervisor, Lubomir Bregman, my reviewer, Richard Bobek, Grammar Learning Corporation, for providing me with partial scholarship, and of course, Alexei Molchinovsky. I do believe that this project would never be done if you would not participate in it. Thank you for your attention. Oh, all right, yeah, and sorry for that. No, that's it. Okay, so now we, of course, I obtain the reviewer questions, and I would like to answer on that. And it was so great indeed, because he pointed me to the places I never thought about. Like, it was a mist from my observation. So he asked me, why do you include the variable which to Cox proportion hazard model regression, which has.
Please speak louder.
You cannot hear. I hear myself, and I think that I'm quiet. My reviewer pointed me out that I use the predictor which has the p-value more than 0.5, and it was just because of my inattention and probably rush. This is my mistake in this case. And here he said that, well, in my work I point out that the first cluster is consists of guys who are churners, and he asked me how it's possible that the CLV, which is predicted, is having positive tendence with revenue, and also it was back and it's already fixed.
That's it?
Yeah, that's it.
You had more questions?
Yeah, he had, but he pointed that.
Not important.
No. He said that the academic board could use them as.
He insisted.
He says it.
He said that we have to be inspired by these questions.
Yeah, but
I'm citing. We are inspired.
Yeah, but at the end, at the like conclusion, he said like it would be not bad if the author would answer this.
Okay.
Yeah, but we can talk.
So this is just for our inspiration.
Yeah.
Thank you. Please send our regards to
Sure.
Okay, finished?
Yeah, I'm done.
Thank you very much.
Thank
you. Do we have any questions? Yes, you do. Good.
Let me just clarify, so I just want to get around saying that. So generally, I really like data science work that you did here, but I want to clarify what was the novelty of the work. So what were these like a new type of model, a new type of research question that you answered, or you just applied the same typical pipelines that are used in retail to a new type of data?
Yeah, I would say the second one, but here's my motivation why I participated in this project. When you're newly baked data scientist, you go to your work and you will most probably receive transactional data. And as a data scientist, you don't know what to do with this because all the data are closed. And if you're not join a company like PwC, McKinsey, or someone who has expertise or who build expertise within the company, there is no chances that when you receive the data, you will have enough time to research in this area because the data is closed. And no one knows what the data set were used in the research. So my attempt was to work with Lubomir on a real data set and try approaches which were mentioned in literature, but there were no details about the features which they were used, also that data set, they were not from grocery stores, and they have like other business requirement, I would say. So this was like replica from the one side, but it was like research because in each step you have the branch of ways you can go, and you have make some assumptions and limit yourself in your investigations. It was with a clustering technique. It was also like we started with time series. There's a bunch of technique. Then also like we predicted churn with survival analytics, but we could use some machine learning for these proposals. If I answer your question.
I would probably develop the question that people asked. How could you describe your results? Are they data-oriented? So you have concrete data, and you develop some pipeline how to model based on this data, or could you give some advice, for instance, for similar tasks? If the data are different, maybe you could suggest that these methods cannot work for any data. or?
So I especially pick, for this research, I especially pick up those metrics which can be in any transactional, those entities which can be found in any transactional data. So it's transactionality, date of purchase, what a person buy, how many of these items, its regular discounted price, and the loyalty card data, because we have to have this relationship to build this historical evidence of his purchases. And after that, we apply clusterization technique, and it's based on these metrics. So I would say that any business could run this framework. It was prototype, but still, I would say any project. And of course, it's a bit like manual, because you have to decide how many clusters you are going to use. It's not obvious. I can show you the results of, let's say, Camins. I know that McKinsey, for instance, they use only Camins, as far as I know. So the first rule that you have to build the dependence within cluster sum of square on a number of clusters, and use elbow method. So while we have this spot of elbow, we should decide how many clusters we have. And then simultaneously you can use other metrics, for instance, this silhouette score. And if you would check, they are not like, it's not a single point. It's some area somewhere there, but it's not a single point. And then you start to explore the data, you start to build distribution of customers among all the clusterization result, and you think that, well, not think, but you attempt to pick up those clusters with like, which are more balanced, more or less. So of course, answering to your question, and at this point we have to like pick up the right number of clusters. Clusterization can be done another way. Let's say if I would have some business requirement, let's say, and it's said that the clusterization should be based on revenue, if it's the case. But for grocery stores, it's interesting. At the end, we are going to make some promo action on particular group of products. So we have to include not only revenue we expect to obtain from a particular relationship with a customer, but also like to see his preferences and how he spent money on this group of products. And then we run Markov Chain model, and we see the general picture, and we can pick up the cluster of interest, like the most interesting for us. And then to see the details, we go to survival analytics and time series revenue prediction. And this is like, for me, it was the most, like, the highest satisfaction when Markov Chain and this econometric approach, they match, they show the same results. So if cluster stable, it's stable in both models. Why I was so satisfied? Because, you know, each model has so many assumptions that can just beat each other, but in this case, no. And so, yeah, this framework can be used for any retail data.
Is there any novelty in that frame? It seems that these are standard tasks that anybody in the field would try.
Yeah, but you have to see this approaches I showed you. It was like maybe the guys used the same, but it was developed after research. It was developed in my head after they like grounded research in this area, because it's like, there are multiple puzzles, and at the end you have to combine them all into one concept. And the same thing is here. You have to decide what kind of clusterization you have to do. You have to decide how would you compare this model. For instance, here I use 4 weeks data, months, 4 weeks months data. Why is that? Because for time prediction, for time series revenue prediction, I use weekly data, and indeed I couldn't match both concepts. So I decided I can go with these 4 weeks, months. And then I plot after correlation function in time series, but it's like step by step. You discover the data and you discover how you will go with this data. So then I saw that after correlations show the lag of 4 weeks, not for 52 as I was expected, because it's like yearly data, it should be some seasonality, but not, it showed 4 weeks. And then I thought like, yes, really, it's United States, and they have the salary each 2 weeks and 4 weeks. And they have promo action, which started on
I just ask you to make a shorter
okay,
explanation.
okay.
please.
But I want to express my feeling before this work. Yeah, sorry.
Would it be an exaggeration to claim that you suggested pipeline which could be used?
Yeah, this is perfect pipeline from my perspective right now. I mean,
Okay,
because
yes.
it's,
Thank you.
yes.
Thank you. May I ask another question? Did you try to identify the clusters? I mean, what kind of customers are?
Yeah, I understand. You mean if I run the persona, right? If I describe the cluster as persona, like. Yeah, no, I didn't do that. I just paid attention on journers because it was interesting. Well, it's also cool. I will show you because it's so cool. You have to know it. You have to know it. So from this transaction matrix, you can derive the following thing. If you choose this first cluster was the second one, right? So the first cluster was formed by journers, and you can.
We have so many.
Yeah.
Okay.
There are so many people in the queue to have a chance, privileged to ask their question.
Okay.
And the very last one, can you show us this Markov chain model?
What do you mean by that?
Well,
like this?
Markov chain.
Yeah, here.
Well, maybe
Model itself. Which model you used to develop?
Slide number, I don't remember.
This one probably.
No.
Yeah, I'm explaining Markov chain here.
You showed it. Well, yeah, this one.
Okay.
I'm puzzled a little bit because on the right-hand side you have a vector or in matrix.
Yeah, it's transitional matrix. It's transitional.
And on the left-hand side you should have a number.
It will be this. Well, it will be this estimate. I'm sorry. Here it will be like matrix, but estimates for each month. So if you would add summation there, it will be the number for particular cluster. But
COB is matrix.
yeah. Oh, here is the same formula. So it will be the representation of this formula will be that matrix of CLB prediction.
Okay, so this is matrix.
Yeah.
Okay, thank you.
And here we have so this is like very simple.
Thank you.
Okay.
I'm satisfied.
More questions?
Yeah, yes, please. So slide number 14, please. And as far as I understand, most of the customers, they tend to stack to their own clusters.
Oh, we can see it from the diagonal elements.
Yes.
Yeah.
So diagonal elements are like they have more probability.
Yeah. And also.
So can you estimate the probability of transferring outside of the cluster?
I mean, here we, from this matrix, we can see the proportion, the probability to come from that clusters to like this one. Like let's say the probability to come to Churner.
So if you also
Okay, that was question not for you, but
so if you check, for instance, this column, we will see the probability of this cluster to come to Churners at the next month.
Okay. And on the slide number 15, you mentioned that Markov chain is rough. What do you mean multiplied?
It's a prediction on a cluster level. So of course it's not individual level. Like if you are talking about the course perspective, something like that.
Then slide number 16. So what this middle diagram? So I mean, what the meaning of this middle?
It was just a piece. Yeah, it was just the visualization.
The numbers. What are they?
It's a number of clusters, the actual number of clusters. So it's showing that. Yeah, this is green, blue, yes. Green, right? So it's the number of clusters, how many people we have there, and it's just like it's represented like funnel, but it's just representation. How many
size of
size of each cluster.
Okay, better if you describe some titles, and then this diagram on the left. So should there be any arrows so we know that people transfer from one cluster to another, or how to treat these streams or threads?
Well, it's just another representation of this matrix.
But is it oriented or not?
No, it's just like a general probability for the cluster. That's why I'm saying that this is like rough estimate. This is probability to for members of cluster to change the cluster over time.
So how do I read it? I mean, if I take cluster number 2, so
you see how they
leave it. So how do I read this? If I have cluster number 2, and then so customer leave it?
Yeah. So customers leave this cluster, and we can see the proportion how they leave it to each cluster. So it's not stable cluster.
So they leave from left to right.
Yeah, they leave. Yeah, it's like current position
so
and
why
it's
do
a position.
Have only 3 clusters on the left, not all of them?
It's just representation. I would just my attempt was to show that depending
then
on
slide 17. And after 500 days, there is some kind of plight or
right.
Dead.
Yeah, because of our data set, we have strict, like restricted system, and in my work, I make some calibration, and yeah, this is like we include for modeling 20, so it's 90 weeks. And the matter is that if person stays with us all this period, so the model predicts
that makes sense to cut only on 500 this chart and stop.
I would say that we are not caring about that long period. We would usually like we run prediction for next month, right, to have some promo actions or something like that, or at least half a year. So they will be started.
Nothing predictions of training data.
No, I mean it's not prediction on training data. Like the model was developed on trained data, but then I have to run the predictions for the future to compare the result with Markov Chain. So I take.
So the prediction period.
Yeah, but for those who were at the last month with our store.
Thank you. Okay, I will be brief this time. If you return, please, to your slide with the data preparation pipeline. Yeah, just to make clear, you have well-structured transactional data, that's right?
More or less.
What needs to be cleaned in such a data?
Yeah, there was a huge problem. It is just selected entities, but it was a problem from my assumption. If I'm dealing with a grocery store, I have to have these features with proportions spent on particular group, but not all items were covered with like higher hierarchy of like group belongings. I mean, so I had to. Well, it was
not classified.
Like yeah, they were not grouped. Yeah, how to say?
Is that many? Because it's grouping or classification of it.
No, I mean yeah. If in
normally means noise removal.
Noise removal or some NAs.
Okay. Okay, and one more question is, Could you please elaborate on the mapping between the objectives and tasks in the project and contributions and results? How do the tasks and objectives map into your contributions and results?
Well, the work.
This is further elaboration of Nicolas and other colleagues' questions.
Well, first task was to investigate existing approaches to CLV modeling. This task was completed. Of course, I started to research this area, and well, I found
all people sitting in the
so I found this like classification, and then
just concisely. This is the task, this is the contribution, and this is the practical outcome.
So the task was to investigate, and we found, with the help of this Pavel Yasik, we found two approaches which could be explored in my work. Then I developed two models, the pipeline and how it will be done with this particular data. I created this, like, cleaned the data, created all the features, and then I ran the modeling. All the results and all the diagrams you see, it was created originally by me, and the conclusions when we compare the models, it's not like I'm taking somebody's idea and I prove that. No, it was like research, result, and conclusion, and based on that we built this framework.
Okay, thank you. You know, the reason to ask this question was that the conclusion slide that you had here in the presentation and the conclusion section in the thesis are different.
Yeah.
This reads better. This
yeah, I know.
reads as.
Yeah, but you know, this version is like 0.
This is correct.
What
you have
right.
written in there. I want to have. Okay. Thank you. And then, more questions? Yeah. Thank you very much.
Thank you.